estimating the square root of a number if it's not a perfect square, we can also simplify the radical. So we're going to simplify the square root of 18. To do that, we're going to start by listing all of its factor pairs. Well, factor pairs of 18 include 1 and 18, 2 and 9, and 3 and 6. Now, amongst those factor pairs, we want to find the greatest factor that's also a perfect square. Well, 1 is a perfect square and 9 is a perfect square, but 9 is definitely the greater one, so that means we're going to work with 2 by 9. So we're going to rewrite our square root as the product of those two factors. So instead of square root of 18, we're going to write that as square root of 9 times 2. Now, we're going to simplify the radical. When we simplify the radical, that means we take the square root of our perfect square, so square root of 9 would be 3, and we leave our imperfect square root as it is. So the square root of 18 would be 3 times the square root of 2, or we would read that as 3 root 2. What happens when we try to simplify a radical and 1 is the only perfect square we have to work with? Well, let's try it here with square root of 10. If we list out as factors, we have 1 by 10 and 2 by 5. So sure enough, 1 is our only perfect square. So that means we're going to be working with the factor pair 1 by 10. So when we rewrite that as the product of two factors, we have the square root of 1 times 10. So now we're going to try to simplify the radical. When we simplify the radical, we take the square root of the perfect square. So square root of 1 is 1 and leave the imperfect 1. So we have 1 times the square root of 10. But 1 is also the multiplicative identity. Anything multiplied by 1 is itself, so we don't generally write it as a coefficient. So we drop that, and we have square root of 10 is the square root of 10. So what this tells us is if 1 is our only perfect square factor, then this is in simplest form, and we can't simplify it any farther. What if we want to simplify the radical, but we're not sure we know all the factor pairs? Well, in that case, we're going to start by finding the prime factorization. So we're going to break square root of 72 into 2 by 36. 2 is prime, but 36 is not, so we're going to break that into 6 by 6. Neither of those are prime, so we're going to break each of those into 3 times 2. 3's and 2's are all prime, so we know we have our prime factorization. So when we expand out our square root of 72, we have 1, 2, 3 2's. So 2 times 2 times 2, and we have 2 3's. So 3 times 3. So now we're going to go through and combine our perfect squares. So 2 times 2 is 4, and then 3 times 3 is 9, but we still have 1 2 left, so it's going to come along still. So now we're going to take the square root of our perfect squares. So when we do that, square root of 4 is 2, square root of 9 is 3, and then we still have our imperfect 2. So when we want to simplify our radical for square root of 72, we're going to go ahead and multiply 2 times 3 to give me 6, and then we still have square root of 2. So square root of 72 is 6 root 2. Check out the other videos in our playlist, and don't forget to click on subscribe. Thanks for watching!